Lesson 8.2 deals with systems of linear equations with three variables. So we've already seen one with x and y. Now we're going to be seeing systems with x, y, and z. So the first example is going to be pretty simple. We have to determine whether the point is a solution. So when you have this kind of problem, which is going to be problem 1 on your assignment, it's going to be really easy. So they're going to give you an order pair. In this case, it's -1, 2, and -2. And they're going to give you a system with three variables, x, y, and z. So these are the three equations. Now, because you have three variables, you end up with three equations. So we're going to have to check that those 3 points, the x, the y, and the z, that they prove each of those equations true. So once again, this is x, this is y, and this is z. So we have the first one. We'll go over and zoom in a little. And it is x. X is -1 plus 2y. Y is 2 minus 3z. Z is -2 equals to 9. So we're testing out the first one to see if it's true. So I have -1 plus 4 plus 6 equals to 9. This is 3 plus 6 is equal to 9. Is 9 equal to 9? Yes. So for the first equation, yes, it is true. Yes, it works. Let's try the second one. 2 times x. X is -1. Minus y. Y is 2. Plus 2z, z is a -2 equals to a -8. This becomes -2, this is a -2, and this becomes a -4. -2, -2 is a -4, and a -4 is a -8. -8 equals a -8. Is that true? Yes. So the second equation works also. So let's try the third one. And if it works for that one, then your answer would be yes, it's a solution. So now plugging it into the third one, -1 plus 3, 2 minus 4, -2 equals to 15. So negative becomes a +1. That's 6. That becomes a +8 because we have two negative numbers. 7 plus 8 is 15. Is 15 equal to 15? Yes, it is. So the answer for this problem would be solution. So it would either be solution or no solution. In this case, it is a solution. Now, you're going to have a little piece of paper that's going to be given to you, or it already has. And it has important rules of solving linear systems in 3 variables. And you're going to glue that, and there's going to be glue for you. You're going to glue that on your notes. So you can have them just in case. If you don't have time to glue it, just leave some space for it to stay there. So, I think I glued it not straight, but oh well. Now let's look at this really quickly and understand what's going on. So it says you're going to reduce a system to 2 equations and 2 variables. So even though you have 3 variables, 3 equations, you're looking for 2 and 2. So that means that we have to eliminate at least one of the variables. And then you're going to pick another different 2, and again you're going to reduce that to the same 2 that you picked before. So once you have 2 systems with 2 variables, we're going to do exactly what we did in the previous lesson. Just solve for x or solve for y or for z, whatever you end up with. And then you're going to substitute back values to figure out the other 2 variables. So the steps are there in case you want to read them and understand them. I basically just summarized them. So let's look to see what example 2 is going to look like. And it might take the whole page, so please bear with me. I am changing pages. I'm going to keep this close by just so I could have it, just in case I need it. So, example number 2. Solve the 3 by 3. 3 rows, 3 columns. That's 3 variables and 3 equations. So the 3 equations that they're giving you are 5x minus 2y minus 4z equals to 3. 3x plus 3y plus 2c equals to a -3. Negative 2x plus 5y plus 3z equals to 3. So these are the 3 equations that we're going to be dealing with. Now, we have to make a decision into which 2 variables do I want to work with. So when I look at this, it would be easier to eliminate, I'm just going to consider the first 2, to eliminate the c's here. Because I would just have to multiply the second one by 2, and I would be able to eliminate this because it's a -4 and a +4 once I multiply by 2. So I'm going to go ahead and take the first 2 equations, and I'm going to write them down here. So this is your problem. Those are your originals. So I'm taking the first 2, 5x minus 2y minus 4z equals to 3, 3x plus 3y plus 2z equals to -3. So once again, I want to solve, and I've already decided, I'm going to put it here, we're going to eliminate the z. That's what we're going to get rid of first. So how can I eliminate the z here? This is a -4, this is a +2. If I multiply this by a +2, that should help with that. So we continue on over here. We didn't do anything to the top one, so we're just going to rewrite it. And there's going to be a lot of rewriting in this lesson, so I don't want for you to be like, oh my gosh, I'm already giving you a heads up. 2 times 3x is 6x. 2 times 3y is 6y. 2 times 2z is a +4z. And 2 times -3 is a -6. So I'm going to look at this, and we're going to end up with one equation. So now I do the addition. I'm going to end up with 1 equation and 2 variables. These 2 cancel, and that was the whole purpose to the multiplication. So these guys are gone, right? I add these. 5 plus 6, that's 11x. -2 plus 6, that's a 4y, equals 3 minus 6 would be a -3. So I've already come up with a new equation, and that's perfect. That's not my answer, but I've done my job so far. Now I have to pick 2 other equations, and just to make your life easy, I would say you pick the second and the third. So I'm going to pick the second and the third. So I am done with this section. I'm going to do a little scribble so it has nothing to do with what I'm about to write. So the second and the third. So when I look at the second and third equation, I need to ask myself, what do I do to eliminate z? Because you have to eliminate the same one. So I have to eliminate z. If I look at it, I have a 2 and a 3. Now, what can I multiply the 2 and the 3 by so I can get the same number? And I can make both of those a 6. So what should I do? I could multiply the top one by 3. So that should give me the 6. And I could multiply the bottom one by a 2. But remember, in order for you to be able to eliminate something when you're multiplying, one has to be positive, one has to be negative. So I'm just going to go with a negative 3. If you chose a negative 2, your answer is still correct. At the very end, it would still be the same thing. Negative 3 times 3 is a negative 9x. Negative 3 times 3 is a negative 9y. Negative 3 times 2z is a negative 6z. And the negative 3 times the negative 3 is a positive 9. So then I have 2. 2 times negative 2, negative 4x. 2 times 5y is a 10y, and 2 times a 3z is a positive 6z, and 2 times 3 would be a 6. So I'm going to look at this. Once again, was our goal accomplished? Did we cancel out the c's? Yes, it was. Say bye-bye to them. I combine my terms, 9 and 4, they're both negative, so it becomes a negative 13x. 9 and 10, they're different signs, so we have to subtract. 10 minus 9 is 1y equals to 15. So I have ended up with 2 new equations with 2 variables. So now that I have these 2 equations with these 2 variables, my lesson, what I would do is what I did in the previous lesson. So I'm going to take those 2. 11x plus, so let me do a little scribble so you know it has something to do with that, plus 4y equals to a negative 3. And I'm going to put the negative 13x plus 4y, sorry, it's not 4y, it's just a y, plus y. We have to make it a 4 in a little bit, so we're going to work with that. So it's just y equals to 15. So we're having to do something. What do I do in order for me to solve both of those? Again, I would have to, here we're not eliminating z anymore. You could either do x or y, but when we look at those, y has the smallest number. So we're going to eliminate y. Now, if this is a positive 4 and this is a 1, what is the common number between 4 and 1? Well, it's 4. That one's already a 4, but I could multiply this one by a negative 4. And that way we should be able to eliminate those. So the top one stays the same. Nothing happens there. 11x plus 4y equals negative 3. The bottom one now becomes negative 4 times a negative 13 would be a 52x. A negative 4 times a 1y would be a negative 4y. And a negative 4 times a positive 15 would be a negative 60. So I'm going to look at this and I'm going to combine them. So I'm putting a little addition sign. You don't have to. Do my y's cancel the way I wanted to? Yes. What is 11x plus 52? that right there is 63x equals, those two are both negative, a negative 63. Divide both by 63, divide both by 63. X equals a negative 1. So I have found the answer to the first one, but I need to go ahead and find the answer to a second one. So I could go back and substitute into this one or that one, whichever you want, because they only have x and y, so it's easier to solve for y. So I have 11, x is a negative 1, plus 4y equals a negative 3. This becomes a negative 11 plus 4y equals a negative 3. So now I would add 11, 4y equals negative 3 plus 11 would be 8. Divide by 4, divide by 4, y equals to 2. So we found x, we found y, and now we have to find z. How do I find z? By substituting x and y into one of the original ones. Now, I would always just say go with the top one, so you won't be wasting time deciding which one. So I'm going to plug it in. I'm going to rewrite it just because it stayed too high up on the page. So I'm going to plug it into the top one. So I have 5. I already know x is negative 1. Minus 2. I already know y is 2 because of this. Minus 4, z equals to 3. So we have substituted both x and y in here. Negative 5, negative 4, minus 4, z equals to 3. These two combined gives me a negative 9. Minus 4z equals to 3. I could add 9, negative 4z equals to 12. Divide by negative 4, divide by negative 4. Z would equal a negative 3. So I have all three answers, and all three answers we're going to write them in one order pair. My answer would be negative 1, comma, 2, comma, negative 3. This is a solution to this system. Negative 1, 2, negative 3. So example 2 kind of took long. So let's look at example 3. Hopefully it's not as long. I don't think it will be. Because it has missing terms, it makes your job actually a lot easier. So let's look at the equations they give us. X plus z equals to 8. So it's missing a y. X plus y plus 2z equals to 17. X plus 2y plus z equals to 16. So because it is missing a variable, right away you should know which variable you should try to eliminate. In this case, because we're missing a y, we're going to try to eliminate, and I can't spell, but eliminate the y. Now, the y is already missing. So I already have one equation with x and z. So this that we did here twice, we're only going to have to do it once because one of them is already given to us. So we only have to do this step once. So for example here, those are original problems. I can't use equation 1 because equation 1 is already missing y. So I'm going to go ahead and take equations 2 and 3. So when I take equations 2 and 3, x plus y plus 2z equals 17, x plus 2y plus z equals 16. So I'm going to go ahead and take those equations. And remember, our goal is to eliminate y because y is already missing on the first one. So what do I have to multiply by in order to eliminate the y? If I have a 1 and a 2, well, we have to make this one a negative 2. So what's a negative 2 times x? Negative 2x. A negative 2 times y, a negative 2y. A negative 2 times 2z would be a negative 4z, and a negative 2 times 17 would be a negative 34. The bottom one stays the same. So then I look at these two equations and I try to end up with only one. So the top one stayed the bottom one stayed the same. The top one we multiply times a negative 2. So do my y's cancel? Yes. Purpose of us doing what we did. Negative 2 plus 1 is a negative 1x. Negative 4 plus 1 is a negative 3z. And a negative 34 plus 16 would be a negative 18. So I have an equation here, but I already have an equation from the top. This one is ready to go. So now that I have both equations, we're ready to go. We're ready to work with those two. So we have x plus z equals to 8 and negative x minus 3z equals to negative 18. So we look at those two and we ask ourselves, can I already eliminate something? Do I have a positive and a negative of a certain variable that I could get rid of? And the answer should be yes. I have a positive x and a negative x. So these guys eliminate. So what do you have left over here? I have 1 minus 3z, which is a negative 2z. 8 minus 8, minus 18 is a negative 10. So I'm trying to solve here. We divide by negative 2. And I find out that z is a positive 5. So I have found one of my variables. Now, who would it be logical for us to find next? X or y? Because I have z, and these two variables only have x and z, it should be that we look for x next. So I'm going to use the top equation. X plus z equals to 8. So x plus 5 equals to 8. We subtract 5, we subtract 5, and I get that x is 3. So now that I have found x and x and z, I have to find y. Now I know in the previous example I said just go with the top equation. Can we really use the top equation for this problem? The answer is no. Why not? Because it doesn't have a y. So then let's just go ahead and use the second one. So let's look at that second equation. Let me bring it in. I'm going to rewrite it. And it's going to be x plus y plus 2z equals to 17. So I'm going to substitute the two values that I know. X, that's a 3. I don't know y, so that stays y. 2, 5 equals to 17. 3 plus y. 5 times 2 is 10. So this becomes y plus 13 equals to 17. We subtract 13, subtract 13, y equals to 4. So my point here, 3, 4, and 5. That would be the solution to this system. Okay, let's look at this new problem. Now, this one's going to involve a little bit of more work, but it is totally doable. So for example number 4, we are given something like this. 3 parentheses 2x plus y plus 5z equals to a negative 1. 2 parentheses x minus 3y plus 4z equals to negative 9. 4 parentheses 1 plus x equals negative 3 parentheses z minus 3y. So the first thing we have to do here is distribute all the stuff that is given to us. So I have 3 times 2, so we have to evaluate this. So this becomes 6x plus 3y plus the 5z equals negative 1. So that one's already set up x, y, z, so we're good. Here we distribute 2 times x, 2x, 2 times negative 3y, negative 6y, 2 times 4 is 8z, and negative 9. Now, if we look at the last one, because they're not going to be in order. So let me go ahead and do the little work over here just so you can see. That's going to become a 4 plus 4x equals, so 4 times 1 was 4, 4 times x is 4x. The negative 3 times z is a negative 3z, and the negative 3 times negative 3y would become a positive 9y. So we have to put them in order. X, y, z equals to a number. So the x is already here, so we're good. We need to move this 9y over, so it becomes a minus 9y. We need to move this negative 3z over, so it becomes a positive 3z. And then we have to move this 4 this way, so it becomes a negative. So these guys go this way, they become the opposite sign. I'm not showing you every step, but hopefully you understand. You move x, y, z to the left side, and you set it equal to the number. So that right there is my fourth equation. My third. So I'm going to rewrite it right here. So these are my 3 equations. And now I do exactly what we've been doing. So it just took that little extra work to do that, but then we're going to be okay. So remember, let's take the first 2 equations. So I'm going to take 6x plus 3y equals to negative 1. 2x minus 6y plus 8z equals negative 9. Now, does it matter who you eliminate? No. But I'm going to say let's go ahead and eliminate x. Now you could do y, you could do z, but depending on which number you pick, it's going to take longer, like we've learned in 8.1. So I think the easiest one is x, because I can multiply the bottom one by a negative 3. If I multiply the bottom one by a negative 3, this here is going to stay, the top one stays. The bottom one, negative 6x, positive 18y, negative 24z equals a positive 27. So then we combine the terms that we can. Was it possible for us to do what we wanted? Cancel those. 3 and 18 becomes 21y. 5 minus 24 is a negative 19z. And this becomes a 26. So I have my first equation, but I remember I still need to go and find another one. So let's continue. So now remember we have to take the second two equations. So question 2 and 3. So question 2, 2x minus 6y plus 8z equals to a negative 9. 4x minus 9y plus 3z equals negative 4. So we're looking at eliminating the same variable, which is x. So in order to eliminate x here, I would have to multiply the top one by a negative 2. So let's go ahead and multiply the top one by a negative 2. So that becomes a negative 4x plus 12y minus 16z equals to an 18. And the bottom one stays the same. So did we accomplish our goal of eliminating the x? Yes. 12 minus 9, 3y, negative 16 plus 3. That would be a negative 13, sorry. So negative 13z equals to a 14. So make sure we know that's a negative. Get rid of that. So a negative 13 equals to 14. So now I have my two equations with two variables. So I have to set those equal to each other. So the first one I have is 21y minus 19z equals to 26. And then I have 3y minus 13z equals to 14. So when I see these two, some of them are kind of big numbers, but I'm trying to eliminate whichever one is easier, and I think it would be 21y and 3y, because if I multiply this by a negative 7, that should help. So the top one stays, 21y minus 19z equals to 26, negative 21y, 7 times 13 times the negative 13 will become a 91z. And please use your calculator for big numbers like this. And the negative 7 times a 14 would be a negative 98. So have we accomplished? Yes, these guys are gone. Negative 19 and 91 becomes a 72z. And 26 and a negative 98 becomes a negative 72. So we divide both sides by 72, and we get that z is a negative 1. So we have found out the first variable, but we still need to find x and y. So once again, who would it be logical for us to find next? Y. So I have 21y minus 19. The z is a negative 1 equals to 26. 21y. A negative 19 and negative 1 becomes a positive 19. Now here we subtract. And I get 21y equals to 7. We divide both sides by 21, both sides by 21. Y equals 7 over 21, but that could be reduced to a 1/3. So yes, maybe some answers will be fractions. It's not going to be crazy fractions. Now, once again, I always say just plug everything back to the first one if it has all three variables. In this case, it does. So my first equation is 6x plus 3y plus 5z equals to a negative 1. So I'm going to plug everything into this one. So we have 6x, 3 times 1/3, plus 5 times a negative 1 equals to a negative 1. Now, 6x, 3 times 1/3 is just 1. 5 times a negative 1 is a negative 5 equals to a negative 1. 6x minus 4 equals to a negative 1. We add 4 on both sides, and I get 6x equals to 3. I have to divide both sides by 6, and I get that x equals 1/2. So my order pair here, it would be 1/2, 1/3, and a negative 1. So all four examples, well actually the last three, they have been solving systems of the 3 by 3, some with missing, some where you have to do some work before you set it up, putting them x, y, z equals to a number. So please be careful. So to guide you, even though I'm pretty sure you don't need it, number 1 is going to be like example 1. Number 2 will be like example 2. Number 3 and 4 will be like example 3, and like number 5, number 5 would be example 4. There's only 5 problems because it requires a lot of work. I expect to see all the work. I don't just want to see answers, I want to see all the work. It would be one of those where I'm really looking for the work. Try your best, work as hard as you can, and please make sure you understand it.